So, welcome everyone to my session of using Selenium WebDriver to automate both the front-end website and the back-end website of using Sitecore applications. I'm Hayder, and my co-speaker, Kushan. Maybe having microphone difficulties. I think you're muted, Kushan, if you want to pop hello early. Okay, I'll let him remediate his. There we go.
You can hear us, right?
I can hear you now. Yeah, so just give a quick.
You can hear me, right?
Yeah.
Okay.
Yep. No worries.
Okay. Hi guys.
Yep.
So I'm Kushan from Sri Lanka, Code House.
Yeah. Cool. I'm just gonna go on to the next slide. So I'm just gonna jump into it and just go on and start talking about how we're going to talk about all the topics in this session. So I'll just briefly be going over a few basics of the difference between manual and automated testing and what scenarios we should automate. As just a quick brief overview of Selenium WebDriver and SpecFlow, which are the two tools we're using to actually get the automated test scripts to work. A demo of both automating the front-end website and back-end website. So when I'm talking about the front-end website, I'm talking about the front-end side of the application that is using the CMS system, and the back-end, I'm referring to the Sitecore UI interface of logging in, experience editor, content editor, index managers, the whole shebang. We'll briefly go over a few challenges we found from automating both the front-end and back-end sites, as they are different in complexity and the HTML is different. So we had to try different ways of automating or targeting web elements for each respective site. Just to call more functionalities that we've implemented on top of the automation, as Selenium's, as it's an out-of-the-box tool, it doesn't have all the implementations, but using other packages and NuGet libraries, we can expand on it. And lastly, we're tackling the main point of how automation of both FE and backend sites enforce shift-left test approach to reduce the number of bugs. So what is the difference between manual and automated testing? Probably everyone's quite familiar with what each one is which. But in short, manual testing is executed by a user being a manual tester or a human, and while automated testing is executed by a machine. And in our instance, the machine is Selenium WebDriver. So we know what we use to automate, but what tests do we actually want to automate? And from a QA perspective, we always want to automate the following areas. So core functionalities of the website. So will be like logging in, a payment journey, searching through the website, making sure the header and footer are displayed, or any other key like profile change password components. So you want to make sure these areas don't break, because that's what everyone's going to spot, especially ourselves or customers. Also, most frequently used journeys. So usually if it's a payment place, you want to make sure payments always working, or if it's like a catalog or with listing items and stuff, you want to make sure you can search correctly and everything can be searched and displayed correctly. Also, time-consuming scenarios. That's because let's just talking about payment, as that's what I'm talking about. If you want to make sure like £5, £10, £100, £5 and 5 pence using sterlings, because I'm based in the UK, and so you want to make sure all of these scenarios work. But if one payment journey takes 5 minutes because the endpoint we're talking to takes too long to process and send back a success or fail response, we don't want to just be sitting there. So we can basically make the automation just do all these scenarios for us, so it frees up or alleviates pressure from manual testing or QAs. And also scenarios that are prone to human error. So if there's like a complex form, or you need to do a certain flow where you need to do the correct toggles and yes and no's or radio buttons and other inputs, if you know it can potentially just fall over if you do one incorrect step, these are ones that are ideal to automate, because the automation will only fail if you write something incorrectly, but it will always write that same values, so you will never have that human error. It will just revoke it completely. These areas that I've just spoke about, they got a common area, which we'll talk about, is regression testing, which as a manual tester, we like to test all of these journeys in general. So every time we do a build, or before and after a build, or doing a deployment to production or UAT, these are the areas which we always want to check. So from our point of view as testers, and from customers' point of view, these are the journeys which we shouldn't ever see breaking. And if they do break, we need to call it out. And with automation, if we automate all these scenarios, we'll be able to find it as soon as possible. So those 4 areas have a common feature of the all automation candidate scenarios. So now you know what scenarios we should automate. I'm just going to jump straight into Selenium. And as we know, Selenium is the tool we're using to write these automated test scripts. I'm just going to do a brief summary of how Selenium WebDriver works. So, a quick overview of it. It's industry standard for automation. If you do a quick Google, or you look at what's being used currently for automation, Selenium will pop up in the top 5. It's open source as well, so there's no additional fee or costs that will just overrun. So that's why it's being used quite often. It's just plug and play, and it doesn't cost much. It also has cross-browser capability with the following browsers. We have Google Chrome, Firefox, Google Headless, which is the Phantom browser or headless browser, and Internet Explorer. So I'm just going to be showing a code snippet of how we've actually got it implemented. So when you're writing this inside the solution, we've done a simple switch case, and we're getting the value of the WebDriver as it's in the config. If we're doing it on the CI/CD, it will come from a variable. But in our config, we've basically set it to either Chrome Headless, Firefox, and IE. So as you can see, it's just a simple switch case where whatever you put, it will just launch that browser. A noticeable difference between these 3 and Chrome Headless is that with Chrome Headless, we need to specify the window browser view to be maximized beforehand, because beneath the switch case, we can see we delete cookies because we want to make sure each test run is independent and nothing causes it to fail, and we maximize the window. But as it's headless, this logic doesn't get applied, so we need to forcefully apply a full screen window view. And also headless runs drastically faster than a UI browser like Chrome and Firefox and IE. So if you want to save time, go for the Chrome headless route. So now I've told you how Selenium works and how it's written in the code. We need to use SpecFlow, which is how we write the BDD test steps, which for us as QAs or testers, we're used to writing BDD in given when then scenarios. So it's not anything quite scary to us. But with BDD, it builds the grounding blocks of writing automation because we bind our logic on top of it. So just going to give a brief overview on how it all talks to each other in the solution itself. So the BDD is written in the feature file. So that's when you write your given when then. So a quick one I would mention is given I am on the Sitecore homepage, if that exists. When the page is loaded, then I can see the logo on the page. So just a quick free given when then. Once I've written that logic, I use SpecFlow to auto-generate, bind those 3 steps I've written into a step file. And then lastly, I'm using the word content editor just for an example, but we'll put the actual logic of the Selenium code inside the page file. So as you can see, it's it's going downwards in the sense of it's all like clustered together. So just a bit of housekeeping. So just to show you how it's done. So here's the feature file that I was just talking about. Just talking about the global footer social media links on our webpage. Once we've generated it, it will look like this in the step definition file. So it automatically, with the SpecFlow plugin, it will automatically generate the code beneath, and we just need to paste it in. But if we do try to execute the test case, it will just fall over and it will just say there's nothing here because it's written pending. So what we need to do is actually write a bit of logic to the step definition. So here what I've done is I've replaced, as I call it, a skeleton code because it's just waiting to be written over. We've just overwritten those two pending methods with two actual Selenium logics. One is from a global class, which we've called driver, and it's got the scroll to bottom logic. And the other one, as I've shown that little vertical diagram, the homepage is going to be a homepage feature step and a homepage class. And it's calling it from the homepage class there. So just going in a bit of tiny depth on what's happening in those two methods specifically. So in the scroll to bottom, we're manipulating the JavaScript driver with the WebDriver and just doing a bit of manipulation in the sense of we want to make sure that it just goes straight to the bottom. And the way we do that is just go to 0, which is the bottom of the page on the web view. And for the other one, it's a bit of a lengthy one, so I couldn't show all of it, but it's another switch case where we've got all the links. But as we can see here, we're doing a few things like we're waiting for the certain item to be available, making sure it's there, moving on to the next step, and then it's just doing a few more checks, and then it goes to the page. So these are just giving a bit of just a small insight of how the logic we use when we're writing automated testing. And yeah, so I've given a brief overview on how it works, what tests we use, and Selenium and SpecFlow. I'm going to hand it over to Kushan right now, and he's going to go over the demo of the front-end Codehouse site.
Okay, thank you, Hayder. So there are a few test scenarios that we will be demoing for this event from our Codehouse test automation framework. The first one is we will show you all how we validate the footer links in our Codehouse on our own Codehouse website, which is done on Sitecore. And we will look at the links like office locations, partner links, social media, how it validates, and also the context as CTA functionality. Then we will check on lazy loading of case studies. How we validate the lazy loading feature, and also validate the office locations in Google. So what we do is when we go to Google Maps, we do kind of a pixel to pixel matching of the Google Maps images and validates whether it's in the actual Google Map has been loaded. Then the video component playing. So we check whether the video component, which is based on YouTube, is being played on our site. So these are the 4 scenarios. So we'll move into the actual execution.
Yeah, so we put a few more scenarios into the session, but because Selenium runs really quickly, we're just capturing a few headliner ones. So you may see these ones interact and a few more. But yeah, I'll just kick it off. And we've got a PowerShell script where with each test case in the feature file, you write a certain tag. So all of the test cases we've tagged here just have, we put FE on it or SUGCON FE, and it's picked up all of those test cases, collated it, and it will run only those test cases. So just giving a brief overview on how we're running it within PowerShell. So, yeah.
So we go into the home page, and now what we do is we actually go and validate the links in the footer. So you can see it runs really fast, as Hayder mentioned.
Some scenarios aren't as fancy as the other clicky scenarios, so bear with us. I think this one still needs a bit of work on, but forces the Google Maps to be accepted.
So this validates the office locations in the Google Maps. The appropriate Google Map link gets loaded for all our branches. In UK, the head office UK, the branches in Sri Lanka and Australia. So there we validate the CTA functionality, whether the links are where the sublinks, the submenu items in the CTA goes to the appropriate subpages, and also the social media links. the Twitter site.
Yeah, so for the session, we've made a smaller test pack, but usually we'll use the automated session to run all of the regression scenarios. Obviously, we don't want the entire presentation of everyone just seeing this screen of Selenium running, so we just did a little cherry picking of a few scenarios just to show its capabilities. So it may drag on a bit, but we have a failover logic for each scenario. So if a test does fail, it will hang for a specific duration. I think for us, we set it to 10 seconds. So when we're running it, it will basically, if a test fails, it will just move on. So in this instance, it seems like it's going to fail. So which we'll briefly talk about in a bit on why it's doing this behavior.
So what we do here is we validate the amounts that are being shown in the statistics module.
And I can confirm that we do have more than 500 fruits a month. I'm one of those people, so. It should terminate. It generates a test results. Yep, cool. So that was the front end one. Now we'll just go into the back end one.
So here, what I have told you all earlier, this is where we actually validate the maps are being accurately loaded. So that there's a kind of pixel to pixel matching of the images. And
Sean, I think we're talking about the back end site. That's on a later slide.
This is where I think we are validating, the image, the video that has been played through YouTube in our Codehouse website.
Kishan, can you hear me?
Which is created based on Sitecore.
Kishan, can you hear me?
Okay. I think we are done, Hayder.
Okay, I think you're behind on the stream, I guess. Connection issues, no worries. So I'm going to move on to the second section, which is the backend Sitecore session. So this is probably what everyone wants to look at. So I'm just going to trigger it and just show you the scenarios. So over to you, Kishan. I think he's dropped off the radar. I think he was having network issues. Didn't want to interrupt him. I can go over these few scenarios. So we just wanted to go through these few scenarios. We're going to create an item, publish an item, and delete an item. We're going to run an index. And we're going to basically make sure the Sitecore user manager functionality is working as expected, and the Sitecore media library, the search functionality works. So we try to collate a list of journeys which we would do as QAs for Sitecore CMS checks, because we usually do that while we're testing components and setting up pages. And a common behavior is usually, there's more of these, but as this is just a snippet of what we can do, these are the ones which show a bit more quirky action. Hopefully Kishan does join us back, else I'll just take over until he comes back. Oops, that's 2 slides ahead. Let me launch this. Yep. So same way, PowerShell Script, it's using a different tag, SUGCON BE. So it's just going to cherry pick a few scenarios. We cleared a cache specifically for the backend site. Kushan, you back? Can you hear me now?
Yeah,
Okay.
I'm back.
Yeah. So
what we do here is we will actually go to the content editor and create a content in the backend. And then we go to, after creating this, we will be adding here the content item, that's a content page. And then we will be validating this in the front end after publishing it. And then thereafter, we will be deleting this. Here, what we do is we go to the media library component in the Sitecore, and we type in a particular media component which is there, and we validate whether the search is working fine. This is the indexing component. So we check the indexing functionality works fine. So we try to do articles web index, reindexing, rebuilding the index.
So for this scenario, we got a timeout, which is a bit longer than our usual timeout, because we know each index, depending on how many items there are, it will take significantly longer to run. So we looked at the estimation time, which Sitecore does provide, and we just plugged that value in there, just like 10 seconds higher than what it states. Because this is our sandbox environment, it seems like it's going to fall over, but usually what happens is, oh, it's actually doing it. Oh. Cool. Don't need to talk about that part. But yeah, once it's completely built, we know that it gives a success message of how many items that were rebuilt, and the test will pass. I think it was set to 70 seconds, so if there's an awkward silence, that's probably why. But but yeah, oh, it's done. I think the 70-second timeout did trigger.
Yeah.
Yeah.
So I think so we're going to click clear the cache.
So do you want to go over why we cleared the cache, Kushan, and we don't do it for the front-end website?
Yeah, because it's like this. So when we go to this particular scenario, the login remains there. So what we want to do is we want to clear out all the data there, so that browser data and everything, and we want to freshly log into the site. So that's why we are clearing off the cache. So we are going to the user manager and validating that we are successfully going to the user manager first. Then we do password reset and also search in the user manager particular user, and also the pagination functionality. Now here we do the password reset. it validates the message.
Just going to check the test runner just to see if it's... No, it's still running. So yeah, while it's hanging, I can just talk about in the test run, it will basically, each given when then, it will give you a timer for each step it takes. So you actually get a overview of how long each actual step take. Even if it's milliseconds, it will capture the millisecond duration. If one section is waiting, it will tell you how long it waited. So it gives an overview of like where it's basically taking longest to execute. I think it's finished because the test runner has collapsed. Yeah, so I'll move back onto the session, the presentation now. Just minimize those. So yeah, Kushan, I'll leave it to you for going over the features that we've implemented. I think I may have lost Kushan again. No worries, I'll step back in again. So we got a screenshot upon failure connection. Yeah, he's gone now. Oh, he's coming back.
Okay. So what happens here is...
Over to you.
What happens here is when there is a failure,
Okay, he's gone again. It's like a magic trick. Okay, so I'll take over from here. So we implemented a tool where we want to make sure whenever a test case fails, it generates a screenshot for us, which is benefit for QAs as well, and for anyone else on the dev team who want to investigate if there's actually a valid bug or the UI is misaligned or there's an error message being thrown. It's easier to spot what the issue is if we can just send a snippet rather than investigating then sending a snippet. So we're able to integrate this tool. Before, you used to send a screenshot when everything was passing, but if it's passing, we really don't want to look at a screenshot. It's better to capture failures. So we just know how to look into it quickly. So as we can see, we've got a screenshot folder, and within each scenario, it will basically generate a folder and give the timestamp of when it was generated. And on the right-hand side, we forced this test case to fail, so it triggered this behavior. And as you can see, it would have a snapshot of where it failed. So Kushan did write this bit of code, but I won't be able to go into too depth. Oh wait, he's back. Perfect timing.
Okay.
Back over to you.
Okay.
Oh, he's
right.
Okay, nice. Yeah. Are you there, Kushan?
You can hear me, right?
Yeah, take off the video if it's causing disruptions. You can speak over this one.
Yeah, I think so. Yeah. So what happens here is it will actually do a pixel-to-pixel mapping. So we don't rely on sizes and width and height. So we do a pixel-to-pixel mapping for accurate checking of validation of the images. So this code is used for the Google Maps validation. So we have expected screen and the actual. So we do a pixel-to-pixel mapping here. Yeah, Hayder, over to you.
Cool, no worries.
Okay.
Yeah. So one of the downsides with Selenium is that it doesn't have its own integrated reporting tool, and in testing in general, we always want to see a report of our test runs because that's what everyone wants to look at. So Selenium doesn't actually have that. So looking at a few NuGet libraries and stuff, we found one called Extent Report, where it's an open source as well. So it works hand in hand with Selenium being open source. So you just need to use both libraries. So when those PowerShell scripts did finish, it generates a test data XML file with like a lot of data, with like the main ones are parse, failure, pending, the timestamp, and how long it took, and all those statistic values. So Extent Report basically grabs that XML file and generates two reporting tools, or two HTML reports. The first one being index.html. So on the left-hand side, it will give you all of the features that you ran. So if you had homepage, login, payment, the lights have turned off above me, never mind. So like you'll have header, footer, if you got to change password, register, make a payment, it will all listed on the left-hand side right here. And on the right-hand side, it will give you a full description of the scenarios that it was executing. So if we're doing our regression pack, it will collate all of these. And as you can see on the left, it will show a tick if 100% of the tests have passed, and if one has failed, it will still show a cross. So we can see in the footer feature, it's got a red cross, but it doesn't indicate everything's failed. It just means something has failed. So it's good to know, okay, it's just this functionality. So in this instance, it was T standing for test. So test 2, the contact us CTA function, something fell over. But yeah, so that's where us as QAs or automation QAs will just dive into and check if there's a valid bug. The second report it generates is dashboard.html. So same with the previous slide with the index, where you got the feature list on the left hand side and the tests on the right hand side. Same extract. You get 2 pie charts. The left hand side showing the total number of features that have passed and the total number of features that have failed. And on the right hand side, you got the total number of tests in the entire run, pass and fail. So it's just they're both showing the same values, but the one that we want to look at is the one that is both more green. So we ideally in the real world will want to get this as green as possible, potentially 100%. But yeah, it changes per deployment or per build or any UI changes that have been done. But it generates 2 readable reports for anyone on the team. So yeah. So one thing that we've done here at Codehouse is that we've integrated our automation test suite to run in the CI/CD pipeline. So whenever we do run a build, it just once it's built the Sitecore side and the website's up and running, it will trigger off the regression pack. So obviously, I just showed you a snapshot of the front end and back end one, but on the pipeline, it takes a bit longer, and it will run all the test cases that a manual query would run, but it's just done automatically. And as we got it done at 1 a.m. it just triggers the automation at 1 a.m. So first thing in the morning, we basically were able to see these reports, so we don't need to wait until it's done. So it's just ready for us. So it's quite handy once the automation is set up in the pipeline. It just alleviates a lot of QA pressure on when we need to do our testing. So I'll hand it. So I'm going to go into a few challenges that we've found while automating both front end and back end. So I think, as we know, the front end side is a bit more transparent in terms of the HTML, and the back end side of Sitecore as is a bit more dynamic. The HTML is, I won't say clunky, but it's not as clear while automating in comparison to the front end side. But both can be achieved, and we found different challenges between them. So I'm just going to go into those. So the first thing I want to talk about is what's the connection between Sonic the Hedgehog and Selenium. And I think we can probably know that Sonic likes to run a lot. So just making a little joke there about both of these like to run really fast. And as great as that sounds for testing, there's also a flaw where tests will just fail because the page hasn't loaded. So let's just say it takes 10 seconds for the home page to load. Automation will just literally just go head first and just start the first test while the page hasn't loaded. So the test will fail, but it will fail because the page hasn't loaded, and it's these loading times that we need to cater for. And in the automation world, we call these race conditions. So I'm going to hand it back over to Kushan, who can go over the race conditions and a bit more about those. Kushan, are you there?
Okay. Yeah. You can hear me, right?
Yeah, go for it. Take over.
Yeah, okay. So race conditions are something like weights that we have because sometimes the internet might be slow when we are going to execute the script, and the infrastructure might be the infrastructure where we host the Sitecore, and the solution might be slow. So when the page is loaded in the browser, Selenium waits for a stipulated time, maybe 2-3 seconds, and if not, it will actually raise an exception, say no such element found, and it will fail the script. So the site is a bit slow, but there's nothing wrong with the solution or everything that we have built. So we had to wait for a while, and So we have to tell Selenium wait for a particular stipulated time rather than just fail in the script with an exception. So implicit wait is what we do is we give a time like 5 seconds, 10 seconds, or 25 seconds, and it actually stays for that particular 25 seconds before going to the next line. But we have another option called explicit weights, where we actually what we do is we give a maximum time that the wait should stay, but we give a condition that it should, if it's satisfied, it will move in rather than waiting for that given time. So for example, we give a threshold time of 30 seconds, but if this particular element is visible that that is located in the web page, it will move in. Like if the element gets displayed within 5 seconds, it will move in, so that it doesn't stay for 30 seconds. So we mostly use the.
I may have lost Kushan again. That's fine. I can take over. Yeah. Okay, he's back. Can you hear me, Kushan? Okay. Yeah, I'll just take over until he comes back. Yeah. So what I was talking about is explicit weights. It weights a certain amount, and if it's found, it will just move on. And then if it doesn't find, we'll have a timeout. But a rule of thumb from doing automation is that use implicit weights as the last resort, and use explicit weights. And the reason for that is in a test pack, if you're automating a regression pack, you're probably going to have more than 100 test cases. And if you think about it quite granularly, you're not going to only have one weight because you're doing multiple steps, there's multiple elements, multiple interactions. There may be a spinner that you need to make sure it's gone. So you're going to be using a lot of weights. And let's just say in one test case, which has 5 scenarios, you have, I think, let's just say that we make it wait 10 seconds each time. But if you just multiply that by the amount of weights you have and then expand that to the entire test run, you realize that you're wasting a lot of time. And obviously, automation should be as efficient as possible. But we're using implicit weights. They do get the job done in some instances, which, like, for example, that Sitecore index one was an implicit weight because that's something that's out of our hands, but we know it takes a bit longer, but we planned it. But for the others, where it's just a spinner loading or the modal is just like populating the content, we use an explicit weight to make sure that the values and CTAs and web elements are interactable. But if you've got 200 test cases and you're waiting 5 seconds to 20 seconds on each one, you can see how that number just quickly just exponentiates. Kushan, are you there?
Yeah, I'm here.
Yeah, okay, no, I just want to make sure. So I'll hand it back over to you about the challenges you found with dynamic websites, which I refer to as the Sitecore UI CMS view. So back over to you, Kushan.
Okay, so the number one we had a challenge is that when we were doing SXA automation in Sitecore backend, we had a toolkit. When we load it through Experience Editor to drag and drop the components, so it was not easily capturable by the direct click operator in Selenium. So we had to use JavaScript to do the click on that arrow component to make the toolkit appear. So then the second one is the frames. So Sitecore had a lot of frames, so we cannot directly interact with components, though we see it. So we had to go to switch to frames in order for Selenium to.
Guess I've lost Kushan again, but I can briefly go back on the frames. So with Sitecore, each modal you see, which you probably don't realize when you're interacting with it, is usually behind an iframe. And the way that the WebDriver works is it can see everything in that view, but if it's within a iframe, it can't see it until it jumps into it. So it's kind of like a restricted view, which you can only see when you're inside of it. So you need to jump into it. Are you back, Kushan? He may be having a few network issues. So with Sitecore, each modal collapsing and expanding, you just need to jump in. Once it closes, jump back out. So Selenium doesn't know what you're looking at, so you need to kind of make sure it's looking at the right view to interact with all the Sitecore UI stuff. We had a few where we had to do a few drag and drops. So speaking about the, we had to use the builder tool. So like for the experience editor, when you're doing a few drag and drops, it wasn't as straightforward as it is with a mouse, where you just click, drag all the way to the viewpoint and just release. But here we had to basically try a very lengthy method of just holding and moving the element, release, and then building the performance. So it looks a bit clunky, but it's a workaround to go through, like interacting through like a really dynamic view. But for us as QAs or developers using Experience Editor, it's just dragging an item. But Selenium is not that straightforward, so we've noticed this as well. So as Kushan's not here, I'm just going to just go through these slides. So with automation, it enforces shift left testing, but everyone's probably asking is, how does it do that? And the way it does that is that I think, is this, oh whoops, yep, so wrong slide. So with shift left testing, what we would like to do is basically test as soon as possible, so we don't wait until like deployments or builds or cutoff points to move to the next environment. We want to start testing ASAP. And with automation, as we're running the regression back, which we usually do to make sure everything's okay, we can ideally start running, do that when the developers are writing code. They can run this build as well when they do a new build. Or if we're in a sprint, we can literally run the automation every day of that sprint. We don't just run it when we do a deployment. And by doing that, we'll find any issues that from any of the developers doing any dev work, we'll just spot a bug. So regarding to front-end and back-end side, if there's a front-ender or back-end working on a few Sitecore-related stuff, or on the front-end side they're working on a few things, as they run these packs, it will basically find these issues and alleviate it. So we'll do early testing. And with automation, if you do it on the CI/CD pipeline, you can do it at 1 a.m. in the morning when everyone's asleep. Wake up in the morning, you got your testing results available for everyone to look at. So yeah, so as I went over, test execution when new code is pushed. So at the end of a build process, we can just basically just make sure that, you know, we don't need to ask a QA, sit down for an hour or two, make sure everything's okay. We can let the QA do some other things, like some exploratory testing or mobile testing or restricted tablet browser stack viewpoint testing. And we can set the automation just do what the QAs would usually check. Yeah, so as I briefly mentioned, it identified the automation test back. Are you back, Kushan? He's still having a few technical issues, I think. So I'll just continue. So yeah, so it will spot all the regression issues, and as they are the key areas of what our customers and ourselves as in the dev team want to make sure that nothing's broken of the core journeys, it does really fix those areas which everyone does want to make sure it never breaks, and when it does break, we know it ASAP. And automating both the front and back end side will reduce the total number of bugs in production. So I think I had this on the previous slide. So by capturing it, we should try to automate on every single environment. It could be a sandbox, can be a release, can be a UAT. It changes for everyone. But we would like to have, it's ideal to get the automation running in every environment, even production as well. We'll probably have a slim test pack because we don't want to be changing passwords and doing live payments with someone's credit card. So, but for all the other environments, we would like to get it running. So as we know, each environment has a different DB or an API endpoint. So some things will behave differently, and we may not see that on our sandbox or sandbox environments because the setup is different. But when it gets to the customer side or on UAT, we've got a different DB or API endpoint. We realize, hang on, something's broken here, and then we capture the issue before it gets into production. So we can do a hot fix or do it in the next cycle in the sprint. But by doing it in all the environments, we can capture any other endpoints which we didn't really think about. But the automation does just fall over when it fails, and that's a sign of something in this particular journey has changed, and we'll just alleviate those. And yeah, I think that's the end of my session. And Kushan, he's back now.
Sorry, guys. The internet is going up and down. Yeah.
Yeah, I think it's something that's going on. But no, we just powered through. But I think that's the end of our session. So it will go on to questions. I don't have a slide for questions, so I'm just going to go back to the first slide. But yeah.
Hello. Thanks for the presentation.
No worries.
We have some questions. This was me. So writing Selenium tests for Sitecore backend sounds complicated because of dynamic HTML. But meanwhile you answered it, I think.
Yeah, so there is like a lot of iframes, and when you expand a certain div, it just shows you a new item. So we did speak about using implicit weights. It's not the best thing to use, but with some websites where it's heavy loading stuff in the background to populate the Sitecore item tree, for example, or experience editor just loading, we just basically be like, let's just wait 5 minutes and hope for the best. Obviously not 5 minutes, let's say 30 seconds, but we let Selenium catch up with what is currently presented to us, and then we do a check to make sure, can we see this item, or can we see this content tree, and does it have this item? If it does, it moves on to the next step. So there's a bit more trickier steps you need to do on Sitecore, but it's still achievable. It's just it's a bit more tricky, but it's possible.
Yeah, we have more questions from Ray. How do you cater for changes in page elements between builds releases? Is there a job to parse known elements?
Kushan, do you want to try to answer this question? If we have Kushan. Yeah.
So actually the page object model allows us to do it. So if there are changes in the page elements, so if we just script from the scratch in all the tests in all the test cases, that means if there are changes coming up in the page elements or there are UI changes, then it's very difficult to maintain and maintain the elements in each go in each of these test cases and do the changes. So that's why we use this page object model, and it's very easy for us to cater these page element changes, so that it's a one-stop place to change the elements. Yeah.
We have the next one from Mark. What's the size and makeup of the team that sets this up and keep tests maintained?
So for us, we usually start off with a bigger team, because if you do have less, I'm just using the number 100 because it's just an easy number. But let's just say we've got 100 test cases, 80 are complex and 20 are quite simple. We want to basically, because you get the most value with automation if you get these packs automated as soon as possible. So first, you just have a lot of people jump in, and we'll help get all those scenarios automated. So we have a larger team, but once it's all complete, because all the automation QAs, they just know how to maintain and make sure if it does fail, how to refactor the web elements to make sure it always passes. So the team does downsize, but it downsizes in the sense that they can focus on another area of automation or work on another project or workload. But it starts off high, and then it just downsizes for this BAU maintenance, just making sure that it doesn't break while the project's going on. I hope that answers that question. Yeah.
Thanks.
Okay.
And we have another one from Anna Maria. So are there any ways to improve the overall time it takes for the automation suite to complete?
Kushan, do you want to give that a go?
Yeah. So to improve the time, we can actually run the automation, as Hayder mentioned in his presentation also. We can use the headless mode, which will actually enhance the speed of execution. That's why the Selenium has also introduced this headless mode to speed up everything, and also to, when we bring up the browser, it means that we use the resources on that particular execution machine. But if we run it on headless mode, the memory and the processing power will be low. so that it will overall improve the automation suite. And also, rather than using the race conditions, when we talk with race conditions, we can use the explicit weight rather than implicit weight. So if we use implicit weight and if we try to accumulate this implicit weight, it might take a lot of time, but explicit weight, yeah, we can increase the amount of, reduce the amount of time and increase the efficiency on execution. Yeah.
Yeah, I can also add a point onto that question as well. So with Selenium, they've also got something else called Selenium Grid. So you saw the test cases running on my screen. It runs sequentially. But with Selenium Grid, you can run different user agents and it will do parallel testing. So depending on how many user agents you launch up, it will run, if there's 3 boxes open, it will run 3 test cases in parallel. So you can see if we implement Selenium Grid, it will just reduce it drastically, but that's a further extension. Which can be done as well. So depending on if you've got 1,000 test case and you've got 10 agents, you'll just have 100 run in parallel, and you can see the time difference will be a bit more shorter.
Thank you. We have one more from Rakuber. My apologies if I did not pronounce your name correctly. Do you have time to tune caches, as some dialogues take more time when loaded for the first time?
I think so. I think the way that Selenium works itself is that the first time it ever loads, or we call it warming up the box, I guess. It does take a bit of time, but once because in the hooks file, which I didn't really go into too much, is where the web browser all gets launched up. It basically stores a few sessions values. So within that, when it reruns again, it doesn't relaunch the entire thing because it's already got stuff in memory, and then I think it just works through that. So it's usually the first test run when I ran both packs, you saw it run slow for the first ones because it was just warming up the servers or the URL that it's looking at, and then it just gets streamlined. But yeah, I hope that answers the question because I haven't actually tackled that area as well. But
I think so. Thank you very much.
No worries.
There are no more questions. If there are more, I think, yeah, they can reach you out or the slides here in the YouTube.
Yeah, and you can always check the YouTube for additional comments or to reach out to the speakers directly. And thank you guys for preparing this, and especially going through all the connection issues and the fire alarms. You survived. You went through it.
Okay.
Yeah, it was good. Yeah.
Thank you, guys.
No worries. Thank you for giving us this opportunity.
Yeah.
Hope
very
it goes
much.
well. Take care, guys.
Cool.
Cheers. Bye.
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 Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.